Hello everybody, this is Dr. Nurbat Shah from University of Engineering and Technology, Peshawar. In this video, I'll be talking about a Gauss Seidel method which is used for solution of system of linear equations. My main focus in this video will be how do we use calculator to find solution of system of equation by using calculator for Gauss Seidel method. At the beginning, I'll be talking about the main steps used in Gauss Seidel method, and then I'll explain an example by using calculator. Now, initially, what do we have? We'll be having a system of equation a11x1 plus a12x2 and so on. This system of equation will contain n variables and n equations with initial guess that is x10, x20, and so on. The first step is again as we have done in case of Jacobi method. You need to if you want to have a convergent iterations, the system of equations must be diagonally dominant. If it is diagonally dominant, that's okay. If it is not diagonally dominant, you need to make it diagonally dominant by using or by interchanging equations with each other. What do we mean by diagonally dominant? In that case, we mean that the coefficient in first equation, if you have this is the first equation, in the first equation, the first coefficient, the coefficient of x1, that should be greater than uh, absolute value of this value should be greater than some of the remaining ones. Like this is a12 absolute plus a13 absolute plus so on up to a1n absolute. Similarly, in the second equation, the coefficient of x2 that should be greater than absolute value of that should be greater than or equal to sum of the remaining ones. Like this is greater than or equal to a21 absolute plus a23 absolute plus so on. Similarly, in the nth equation, the coefficient of xn, which is ann, its numerical value should be greater than, that is ann absolute should be greater than or equal to sum of the remaining ones, an1 absolute plus an2 absolute and so on. If a system of equation is satisfying these conditions, in that case we say the system is diagonally dominant, and then the Gauss Seidel iterations, they will be converging. Once we have checked that, the next step is what? We will be solving equation number 1 for x1 and then introducing the iterations x11 by using the previous values. The previous values, as we assume that is x10, x20, these values could be 0 as well. The simplest ones are taking all these values 0. Right, you can take any values, you may take 111 as well. Okay, so by using these values here on the right side, we'll be finding the new value or the updated value of x1. And the next equation, which will be solved for x2, but the difference from Jacobi method is we'll be using updated value in this case for x1. In Jacobi method, what do? We use the previous value, the initial value, which is 0, but in case of Gauss Seidel, what would we do? We'll be using the new updated value. If you want to do this equation by using Jacobi method, then this will be 0. In case of Gauss Seidel, this would become what? This will become 1. Similarly, the third equation, will be solved for x3, and then by introducing the previous updated value as well. And generally, if you want to solve the nth equation, so nth equation will be solved for xn. Okay, and then the updated value of xn, which is represented by 1, that will be obtained by using the updated value of x1 instead of using x10, which was done in case of Jacobi method, x20 in case of Jacobi method. But in case of Gauss Seidel, what do? We will be using x11, x21, and up to xn minus 1, which will be updated in the previous equations, like here in this equation, and many equations in between them. More generally, what do? We simply write the Gauss Seidel method for I is equal to 1 to up to n. we write this equation as xik plus 1. That's a bi, you see that b1, b2, b3 and so on. Whereas if I is equal to 1, if you are doing this for first equation, obviously this term will be vanishes, because we are having j equal to 1 up to 1 minus 1 0, which is not possible. So this term will be vanished, and we'll be having only b1 minus a 2 1, because we are starting from j equal to I plus 1. So we will having the same thing, you see. Well, in the second equation, if you see, if you put I is equal to 2, that will become 1 over a to 2. This is b2 minus, and in this case you see you have be having a to 1, whereas x1, and that will be what? That will be k plus 1, and the remaining will be k, and so on. So this is general form of Gauss Seidel method, and we have also a general form for Jacobi method. In case of Jacobi method, this will be also k. Okay, this term will also be k. Okay, now let's solve a system of equation by example. So let's consider an example that is 10 times x1 minus 2x2 minus x3 minus x4 with initial conditions, our initial values, that is 0 0 0 0. That means x1 x2 x3 x4 are all taken initially 0. Now, first step is, I said, you have to check whether the system is diagonally dominant or not. For that purpose, the coefficient of x1 in the first equation is 10. This is 2. Forget about the negative sign. This is 1. This is 1. Now, 2 plus 1, that is 4. So, 10 is greater than 4. So, equation number 1 is satisfying this condition. Similarly, in equation 2, we'll be having coefficient of x2 is again 10, where the remaining has a sum 4. In this one, the third coefficient, the x3 coefficient is 10, and the remaining sum is again 4. Whereas in fourth equation, the coefficient of x4 is 10, and the remaining sums are again 4. 1, 1, and 2 is 4. So 10 is greater than 4. It means this system of equations is diagonally dominant. So if we use either Jacobi iterations or we use Gauss Seidel iteration, the iterations will be convergent. So what do we do? The next step is, once we have checked whether the system is diagonally dominant or not, once it is, then we do what? We solve the first equation for x1, leaving x1 to the left side and taking all these things to the right side. Then equation 2 will be solved for x2, so leaving x2 on the left side and taking everything to the right side, and so on. So if you do these steps, we will be getting a system of equation in this form. Right, and now from here, basically we'll be differentiating, or will be making difference between Jacobi and Gauss Seidel. In case of Jacobi, if you want to find the first iterative value of x1, so make this 1, we'll be taking this is 0, this is 0, this is 0. That's the previous value we'll be using. In Jacobi, if you find x2 1, so we'll be doing what? We'll be taking 0, 0, and 0. For x3, the same thing. This is x1, this is 0, this is 0, this is 0, and so on. This is 0, 0, 0. Whereas in case of Gauss Seidel, we are basically doing, or we are using these values in a different way. How do we do that? So again, if you are updating the value of x1, so you just take 1 here, and it's similar to Jacobi, sorry, it will be 0, 0, 0. But when we come to the second equation, if you want to find x21, what will we do? We'll be using 1 here, because this value is now updated from previous equation. So we use x11 here. We'll be using 0 and 0, because we don't have updated value of x3 and x4. We'll be using the previous values of x3 and x4. To find x31, keeping in mind we have updated value of x1 and we have updated value of x2. So we will be using x11 and we will be using x21, whereas we don't have updated value of x4. So we take x4 0 here. And for x4, what will we do? We'll be using updated value of x1, updated value of x2, and also updated value of x3, and so on. The same thing for x2 as well. If you go for x2, so this will be x1, x2, 3, 1, x4, 1. But when you find x2, 2, this will become x1, 2, whereas this is 1, this is 1. That's the way to do it. Generally, if you are going for k plus 1th iteration value, So x1 k plus 1 will be using the older values for k is equal to 0, 1, 2 and so on. When we come to the second equation, what happens x2 k plus 1, now we will be using the updated value of x1. You see x1 k plus 1 from here, from the previous iteration. Then for x3 k plus 1 we use x1 k plus 1 from this one and x2 k plus 1 different, whereas x4 k will be used here and so on. Right, now what will we do? Initially we put x2, x3, x4 to be 0, because initially we have observed that x1 0, x2 0, x3 0, x4 0, they are all taken to be 0. So what would happen in the first value? If x1 1 will give you what? X1 1, that will give you 3 by 10, because the remaining will be 0. This will be 0, this will be 0, this will be 0. When we find x2 1, what would happen? X2 1, in that case we'll be taking 15 plus 2 times, now value of x1 1 is this one, so 2 times 3 by 10, the remaining will be taken as 0 and then divided by 10. For x3 you will be using this value for x1 here and this value for x2 here, whereas x4 will be taken as 0 and then you get x3 1 and so on. Okay, next I'll explain how do we use calculator for finding all these values. Okay, and how do we do that? The concept is very simple as compared to Jacobi, right? So in Jacobi we usually use different type of notations for the right values of x1, x2, x3, x4 and different type of variables for the left side. But in case of Gauss Seidel, we will be using same variables on both sides. So the first step is you need to have convert the mode of calculator in math mode. That is, you just press mode and then press 1 here to convert that into math mode. So you should have a math mode and you should have a radian mode as well. Now we just write equation directly from here and you say we are calling x1 to be a, x2 to be b, x3 to be c and x4 to be d, or you can obviously call it e, f, x, y as well. It's up to you whichever variable do you want to name that or label that. So the first equation is used for x1. Okay, so I'll just write alpha and then I call it a, then alpha, press equal and then I go for the fraction and then we have 3 plus 2 and then I'll use b for x2 as I said earlier. So x2 is replaced with b and then we have plus x3 which is c, then we have plus x4 which is d divided by 10. And then we'll be introducing separator, this one. Then the next equation, that's x2 which was denoted by b, so we take b equals this one equal and then go for the fraction and then we have 15 plus 2 x1, so x1 which was replaced with a or which will be replaced with a plus, then we have x3, so x3 which is c, then we have plus x4 which is d and then divided by 10. Then separator and x3 which is replaced with c, so we just put in c here and then equal, then introducing this fraction, this is 27 plus x1 which is a plus x2 which is b and then we have plus 2 times x4 which is d divided by 10. Then having a separator and go for x4 where x4 is what? That is d, so d equals, sorry my fault, so d, this one equals and then go for the fraction, it's minus 9 plus x1 x1 that is A plus x2 which is B plus 2 times x3 that is 2 times C divided by 10. Right, so now we are done with it, so I just simply press calc. It will ask about the value of B first because we are using B first in the equation. I just give you 0 equals C is also 0, this is equal, then we give D which will be 0 as well, that's equal, and then it will give you the value of A. Let's go to the table where the values are found. You see, so it is finding the value of A, that is 3 by 10 which is 0.3. So the first value of x1 which is A, obviously in this case, that is 0.3. the next press, that will give you the next value which is 1.56, then press equal, may convert into decimal point, that is 2.886, then press equal, it will give you minus 0.1368. next time we just press equal to get the value of B, next value of B which is 1.56. so we don't need to replace that value, just press equal, press equal, press equal, and that will update the value of A. So A is what, 0.8869, then press equal, that will give you 1.952304, then press equal to get the value of x3, press again equal to get the value of D as well, minus 0.0248, and then you will be simply pressing the key, equal key, and to get the updated values. You don't need to change any, do anything with this, just simply press equal, B, C, D, and then it will find the updated value of A which is 0.9836. Next equal key pressing give you the value of x2 1.9899. again press the equal key to get the next value, and so on. So see, again press equal, you don't need to change the value of B, it will remain the same, so it's just equal, again equal, equal, and see D is getting close to 0, so A will be 0.99 and so on, 68 now, and then B, C, and D is getting closer to 0. Press again equal, you'll get the value of A now 0.99994, 2677, and so on. So then the next value is B, and so on, so on. So in this case, in case of using Gauss Seidel method, what will you do? You will be simply pressing this equal button and no input value for A, B, C, D later on. I hope it's clear to everybody. So after 7 iterations almost, you will be converged to the actual root. In this specific system of equations, Gauss Seidel method is performing better than Jacobi method in comparison. Thank you very much. If you have any question, you can simply drop me a message. Subscribe to my channel. Thank you very much. See you in next video.